Hello everyone, today we have this medium problem, remove nodes from linked list. So in this problem we are given a linked list, and what we have to do here is we have to delete nodes from this linked list such that they have a value greater than the value in that node in ahead of the linked list. So what does this means is that if we look at this 5, we have this 13 and this 8. Any one bigger value is sufficient. So for, let's say for this 5 we have this 13, so we must remove this. We remove this 5. For this 2 also we have this 13, so we remove 2. For this 13 we have no such number in front of 13 such that its value is greater than 13, so we will have to keep this in the list. And for 3 we have this 8 which is greater than 3, so we will remove this. So what we are left with is 13 and 8. Okay, so that would be our answer for this example. I will be showing you two approaches to solve this problem. The second approach will decrease the space complexity from O of n to O of 1, that is to the constant space. Okay, so let's see the first approach. So first we are at 5. So let's say we have 5 in our linked list. Then we got 2. And now 2 is smaller than 5, so we can insert it in the linked list. Okay, now when 13 comes, we see that 13 is greater than both of them, so we need to remove both of them. Okay, and now comes 3, so we can insert 3 also, because the 3 is lesser than 13 but it is after 13. Okay, so 3 will be part of this linked list. But now when 8 comes, 8 is greater than 3, so we remove it, but 8 is greater than 8, so we cannot remove 13, so we just remove 3 and insert 8 in our linked list, and that would be our final answer. So how can we do this programmatically? So let's say we have a stack here. Okay, we have this stack. So in this stack we will be pushing the elements that we got. Okay, so first we have got this 5. Our pointer is currently at 5, so we will push 5 into the stack. Then second, now 2 is lesser than 5, so we can insert it, so then we insert 2. Now 13, if we see 13 is greater than 2, that is top of the stack, so we will remove 2. And now the top of the stack is 5, and 5 is also lesser than 13. Okay, whatever is present in the stack denotes the numbers which are on the left hand side. Okay, so if we are at 13, so if that is greater than the left hand side elements or the elements in the stack, so they should be popped. Okay, so we will pop 5 also, and now we will push this 13. Then we'll move to 3. Now 3 is lesser than 13, so it's on right, it will work, so we'll push 3. And now we have 8. 8 is greater than 3, so we need to pop 3 and insert 8. And then we see that okay, 13, but 8 is lesser than 13 and it's on right side, so it will work, so we won't pop 13. And so when we reach the end of our linked list, we will have the elements in this order. Okay, so now what we have to do here is we will have to make a linked list out of them. So we will pop 8. Okay, and let's say this is our answer pointer, so our answer will be pointing to 8 now. Okay, and now we will again pop until it's the end of the stack, so then we will get 13. So we will say 13, we'll make a new node of 13. Okay, and 13 next will be pointing to the 8th node. Okay, and then answer will be pointing to 13. So what we are doing here is we are inserting at head. Why? Because if we look at stack, it's gonna give us the number in reverse order. Okay, so what it gave us was 8 and then 13. Okay, so 13 should be before 8 because we have to see the order in this way. So that's why we inserted it at head. Now let's move on to the second approach. We are first going to reverse the linked list. Okay, so just wait for a second and let's see how does the reversed linked list look like. So what was originally our question? Our question was that for any node, we must delete it if there exists some node which has greater value. Like for this 5, 13 exists. So we have to delete this 5 only. Okay. If we reverse the linked list and try to restructure the question, then what we can think of is that for any number, if we reverse it, on right of it, there should not be a number lesser than that. Okay. There should not be a number lesser than 8. Why? Because if there is a number lesser than 8, so in the original order that we reverse it, so that would be like this 3, 18, and we see that for this 3 we have now 8 greater than itself, so 3 should be deleted from here. So if we reverse it and try to traverse the list from here, so we can see that for every number we need to ensure that the next number to it is greater than from the current element. Okay. So what would happen is for this 8 we will check its next element. Okay. If it is less than that, so we will remove it. So we will remove this 3 and now the next of 8 will be pointing to 13. Okay. So now 13 is greater than 8, so we'll move our current pointer ahead. Now we will see that the next pointer of the current pointer, that is this next pointer, is pointing towards 2, which is lesser than 13, so we will remove it and now it will point to this node. And again we see that now the next pointer is pointing to 5, which is again less than 13, so we'll have to delete it also. Okay. We'll delete it and the next pointer will now become null. So we have reached the end of the list. And now what the list we are left with is 8, 13 and then null. So we will again have to reverse it to get the final answer. So 13, 8 and we will get the answer. So what we have done here is first we reverse the linked list. Okay. Then we remove if any next element is lesser than current element, and finally we reversed the linked list again, and that's would be our answer. Now what you might be thinking here is that why have you reversed the linked list and checking if any subsequent element is lesser than that? Why not just keep the list as it is and check if the element is greater than this, so delete the current element. Okay, so that wouldn't work because let's say this is 5 now and this is 2, so we'll check it is lesser than that, so we will increase the pointer and now this becomes greater than 13, so we will remove this 2. So how can we remove this 2 is by doing this 5 going to 13, and that is not possible because we don't have track of that element. Okay, because we have increased the current pointer, so we couldn't do that. Okay, that's why we have reversed the linked list. I hope you have understood this concept. So comment down if you have any better solution to this problem, and the link to the solution or the code of this problem is attached in the description. Okay, so bye bye.